Permutations and Combinations Part 2. Find the number of permutations, 9 objects taken 2 at a time. So here we want permutations, and our formula for permutations is Pn choose r, and that equals n factorial over n minus r factorial. First, we need to identify the n and the r. N represents the total number of objects that we have. So there's 9 objects, and n equals 9. Now we're taking 2 objects at a time. R is the number of objects that we're selecting, so R equals 2 in this case. We'll just plug those values into the formula and solve. We have 9 factorial divided by 9 minus 2 factorial. We'll do the subtraction on the bottom, so we have 9 factorial divided by 7 factorial. And we can write this out as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on the bottom we have 7 factorial, which is the same as 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we'll cancel factors on the top and bottom. So I have the 7 times 6 times 5 and so forth in common on the top and bottom of the fraction. So I'll cancel those out, and I'm just left with a 9 times 8 on top, and 9 times 8 is 72. So the answer to this problem is that there are 72 permutations. Now I want to find the number of combinations, and I have 11 objects taken 4 at a time. The formula for combination is Cn choose r, and we have n factorial divided by n minus r factorial times r factorial. And n again is just the total number of objects, which is 11, and r are the number of objects that we're selecting, and that would be 4. We'll just plug those values into our formula, and we get 11 factorial divided by 11 minus 4 factorial times 4 factorial. We'll do the subtraction in the parentheses first, so we have 11 factorial divided by 7 factorial times 4 factorial. Alright, so I wrote out 11 factorial and 7 factorial and 4 factorial within my problem, and now I'm going to cancel like factors on the top and bottom. I always take the larger factorial because then I'm canceling the most amount of factors. So I'll take the 7 times 6 times 5 times 4 times 3 times 2 times 1, and I'll cancel that out on the top and bottom. Now on the top I'm left with 11 times 10 times 9 times 8. And on the bottom, we're left with 4 times 3 times 2 times 1. If I do 11 times 10 times 9 times 8 on the calculator, I get 7,920. And when you multiply 4 times 3 times 2 times 1, you get 24. Next, you need to divide 7,920 by 24. And when you do that division, you get an answer of 330. So the final answer to this problem is that there are 330 combinations.